So today we are going to learn about vector addition. There are two ways of vector addition. First is the triangular law of vector addition and second is the parallelogram law of vector addition. So let us concentrate today on the triangle law of vector addition. The triangle law of vector addition. Suppose there are two vectors, vector A and vector B. Now we need to add these two vectors. Adding these two vectors would give us a resultant vector in another direction. It is quite clear. See, this is one vector and this is another. If you add these two vectors, then you can clearly see the resultant would be in this direction. Resultant would be in this direction. The resultant vector can be drawn according to triangle law of vector addition as this. If this is vector A and this is vector B, then this would be the resultant vector. Now how to add two vectors? See, while adding two vectors, you have to keep in mind two things. The vectors that you are adding, vector A and vector B, they should be head to tail connected. They cannot be head to head connected. You cannot add two vectors. You cannot add vector A and vector B in this way. This is not possible. The only way possible to add two vectors is by connecting it head to tail. That is, the head of one vector, say for example, vector A, should be connected to the tail of the other vector. This is the way of connecting or adding two vectors, A and B. And the resultant that would be formed after adding these two vectors should be drawn in a way such that the tail of the resultant touches the tail of one of the vectors that you are adding, and the head of the resultant touches the head of the other vector which you are adding. This is the sequence to add two vectors. If there are two vectors A and B, then we get a resultant vector R. This is how vectors are added. If there are two vectors, vector A and vector B, then the resultant, this is the resultant, we'll get by just adding the vectors A and B. Now adding the vectors A and B does not mean that you can add the magnitude of these vectors. Suppose, let's say, the magnitude of A is 5 meter. Now, if you concentrate, if you see, now see, I have written the magnitude in this, that is vector within the modulus. This is the modulus. This is called the modulus symbol. So whenever you want to write the magnitude of a vector, you have to write in this way. Either the modulus of the vector or just the letter A with no vector symbol above it. You got it. So this is the way to write the magnitude of a vector. Either write the letter that symbolizes the vector or write the vector within the modulus. This is the way to represent the magnitude of a vector. Now, suppose the magnitude of vector A is 5 meter and that of vector B is 10 meter. By normal addition, it may seem that we just add the magnitudes, which would give us 15 meter. But this is a completely incorrect method. You cannot just simply add the magnitudes while adding two vectors, because notice, this is not the same as this. Is it the same? It does not have a modulus symbol. Does it have? It does not have a modulus symbol, whereas this has a modulus symbol, which makes a complete difference in the addition of vectors. So while adding vectors, you just cannot go on simply adding the magnitudes of two vectors. You have to take into consideration the direction. So when you take into consideration the direction of this vector, then the value of the magnitude, which is 5 meter, this changes. As a resultant, what happens? As a resultant, the whole value of the resultant vector changes. अगर ये 5 मीटर चेंज होता है और ये 10 मीटर का वैल्यू चेंज होता है, कैसे चेंज होगा? क्यों चेंज होगा? चेंज इसलिए होगा क्योंकि ये जो वेक्टर A है यहाँ पे, ये जो वेक्टर A है, इसका मैग्नीट्यूड का वैल्यू है 5 मीटर. अगर इसमें डायरेक्शन जोड़ा जाए तो इसका वैल्यू 5 मीटर से ज्यादा भी हो सकता है, कम भी हो सकता है. इसलिए दोनों वेक्टर्स का एडिशन करके जब हमको रिजल्टेंट मिलेगा, ये रिजल्टेंट का वैल्यू 15 मीटर कभी हो ही नहीं सकता. सो वी हैव टू फॉलो सर्टेन रूल्स. वी हैव टू फॉलो सर्टेन रूल्स which clearly indicates that addition of two vectors cannot be done by simple addition. As I have told earlier, in the triangle law of vector addition, let us consider two vectors. This is vector A and this is vector B. How to add these two vectors? Usually, the diagram which represents the addition of these two vectors I have drawn earlier, it would be like this. The triangle law of vector addition. Now what do we do at first? We do a simple construction. Extend this vector A such that it becomes perpendicular to the point where vector B meets the resultant. As a result, we get a right angle triangle O and Q. This is the right angle triangle that you get. Now, the vector A and vector B are inclined at an angle theta to each other. A और B के बीच में जो एंगल है वो है थीटा. A और B थीटा एंगल के डिफरेंस पर है. डायरेक्शन वाइज अभी हम दोनों को ऐड करेंगे यूजिंग पाइथागोरस थ्योरम. ठीक है, यूजिंग पाइथागोरस थ्योरम वी आर गोना सॉल्व दिस रिजल्टेंट वेक्टर, find its magnitude, and hence we will be getting the triangle law of vector addition. So what is the first thing that we do? Thing is that we name this point as P. Using Pythagoras theorem, we get that in this right angle triangle, in the right angle triangle O and Q, we get ON square plus QN square is equal to OQ square. This is as simple as that. Now the thing is that we don't know ON, we don't know OQ, we don't know QN. What is ON? ON is OP plus PN. ON is OP plus PN. See, ये ON है, ये OP और PN का क्या है? एडिशन है. ON is OP plus PN whole square plus QN square equals to OQ square. Now see, this is QN, this is OP, this is PN, this is OQ. See it, OQ is actually what? Vector R. ये है, yes. OP is vector B, magnitude vector B. देखिए, OP के QP क्या है? Vector B है. What's OP? OP is vector A. This is it. Then how do we find Qn? We know OQ, which is R. We know OP, which is A. But we need to find Pn and Qn. We need to find Pn and Qn. How to find Pn and Qn? So, in this right angle triangle, Q and P, if you apply trigonometry, then we find that sine of theta will be equal to sine of theta. Sine theta means perpendicular by hypotenuse. It will be equal to Qn by QP. Okay? यहाँ पे Qn क्या है जो हमको निकालना है यहाँ पर बिठाने के लिए, और QP क्या है? QP is B. Therefore, Qn is equal to B into sin theta. B into sin theta. What is the value of Qn? It's B sin theta. Similarly, in triangle Q and P, in the same triangle, cos theta is equal to, cos theta means base by hypotenuse, Pn by Qp. We need to find out Pn. Therefore, cos theta equal to Pn by Qp. What is Qp? B. So, Pn equal to B into cos theta. B into cos theta. So, substituting the value of Qn, which is B sin theta, and Pn, which is B cos theta, here we get, substituting the value of Pn, which is B cos theta, and Qn, which is B sin theta, into this equation, we get OP plus Pn means B cos theta. B cos theta whole square plus Qn square, which is B sin theta whole square. B sin theta whole square, which is equals to OQ square. And what was OQ? OQ is R, QP is B, and OP is B. So substituting these values in this equation again, we get OP, which is A, plus B cos theta whole square plus B sin theta whole square, which is equals to OQ square, and OQ is R, which is R square. Now if we solve this equation, we'll get the different formula. Let's try it. A plus B whole square. A plus B whole square formula. A plus B whole square, which is equals to A square plus B square plus 2AB. Applying this here, A square plus, what is B? B is B cos theta whole square. B cos theta whole square plus 2AB. 2 is A, B is B cos theta plus B sin theta whole square. B sin theta whole square, which will give you R square. Further solving it, A square plus B cos theta whole square is B square cos square theta plus 2AB cos theta plus B sin theta whole square is B square sin square theta, which is equals to R square. Now we have to reduce this equation. How to reduce it? Series term B cos theta, B square cos square theta, and this term b square sin square theta. We can combine these two terms to reduce this whole equation. Let's write it together. A square plus 2ab cos theta plus b square cos square theta plus b square sin square theta. See, we have written these two together, which is equals to r square. Now, a square plus 2ab cos theta plus b square is common. Let's take it common. What is left inside is cos square theta plus sin square theta. We know that cos square theta plus sin square theta is equal to 1. Therefore, our next equation becomes a square plus 2ab cos theta plus b square into cos square theta plus sin square. Cos square theta plus sin square theta is 1. So b square into 1, which is b square, is equal to r square. Therefore, if we need only r, then this square would be converted into root over in this side. A square plus b square plus 2ab cos theta equal to r square equal to